Hello and welcome to TutorTube, where the Learning Center's lead tutors help you understand challenging course concepts with easy-to-understand videos. My name is Rebecca, lead tutor for biology and chemistry. In today's video, we will explore polar and nonpolar compounds. Let's get started. First, let's define polar and nonpolar molecules. A polar molecule occurs when there is unequal sharing of electrons within a bond. A nonpolar molecule occurs when there is equal sharing of electrons within a bond. Let's see some ways to distinguish nonpolar molecules from polar molecules. Whenever you see a monatomic atom such as helium, neon, argon, and so on, it is nonpolar. Whenever you see a diatomic molecule of two identical atoms such as nitrogen molecule, chlorine molecule, hydrogen molecule, and so on, there is equal sharing of electrons between the atoms involved, therefore these are also nonpolar. Another way to distinguish nonpolar molecules from polar molecules is to see if the compound is only composed of carbon and hydrogen atoms. So whenever you see a hydrocarbon such as methane, ethane, benzene, and so on, it is a nonpolar molecule. But when you're dealing with compounds that are not diatomic, monatomic, or even hydrocarbons, check to see if the compound has a symmetric distribution of charges. Such a compound typically has a central atom that bonds all of its balanced electrons equally to identical terminal atoms. Let's take carbon dioxide as an example. Since the central atom carbon bonds all four of its balanced electrons equally to two terminal atoms oxygen, it has a symmetric charge distribution and is therefore nonpolar. Another example is carbon tetrafluoride, in which carbon as the central atom uses all of its balanced electrons to share equal bonds with four fluorine atoms. This compound has a symmetrical distribution of charges, and so it is nonpolar. One last example is boron trifluoride. The central atom boron uses all three of its valence electrons to share equal bonds with three fluorine atoms, so this compound is also nonpolar. Calculating the electronegativity difference between bonded molecules can also help us determine whether a compound is nonpolar or polar. If the electronegativity difference is less than 0.4, then the substance is nonpolar. For example, in the compound iodine monobromide, iodine has an electronegativity value of 2.66, while bromine has an electronegativity value of 2.96. The electronegativity difference between these two atoms is 0.3, which is less than 0.4, therefore iodine monobromide is a nonpolar molecule. We can also identify nonpolar molecules by checking to see if there is zero net dipole moment in a compound. Take trans-dibromoethene for example. In this compound, two carbons are bonded to bromine and hydrogen atoms in trans configuration. Bromine is a more electronegative element compared to carbon. Therefore, the bonded electrons shared between them are more attracted towards bromine, making the dipole moment in the direction towards bromine. While the bromine bonded to the first carbon is attracting the bonded electrons towards itself, the bromine on the second carbon is doing the same thing except the dipole moment is in the opposite direction. Therefore, the dipole moment in these two bonds cancel each other out. In the bond between carbon and hydrogen, since carbon is more electronegative than hydrogen, it is going to attract the bond electrons towards itself. Since the carbon-hydrogen bonds are in trans configuration, these two bonds will also cancel each other out. Therefore, overall, there is going to be zero net dipole moment, making the entire compound nonpolar. Now let's see how to distinguish polar molecules from nonpolar molecules. First and foremost, if a compound has hydrogen bonding within it, it is a polar molecule. This means that if there is a hydrogen atom directly bonded to fluorine, nitrogen, or oxygen, then it is a polar molecule. Even when it comes to methanol, where the methyl part does not have hydrogen bonding, the entire compound is still considered to be polar because the hydroxyl group involves hydrogen bonding. If the compound you're looking at has an asymmetric charge distribution, then it is a polar molecule. The compound methyl chloride has 3 hydrogen atoms and 1 chlorine atom bonded to the central carbon. Since carbon is not bonded to identical terminal atoms, there is an asymmetric charge distribution in which most of the electrons will be concentrated around the chlorine, as it is the most electronegative element in the compound. This makes the compound polar. Similarly, trichlorofluorosilane has an asymmetric charge distribution because one fluorine atom and 3 chlorine atoms are bonded to the central atom silicon. There will not be equal sharing of electrons because the terminal atoms are not identical. Thus, this compound is polar. Let's take a look at sulfur dioxide. You need to draw out the Lewis structure to see if its charge distribution is symmetrical or not. Sulfur forms a double bond with each oxygen and will be left with a lone pair. This molecule will have a bent molecular shape because of the lone pair on the central atom sulfur. The charge distribution is not symmetrical, making it a polar molecule. If you see two atoms with great electronegativity difference bonded together, it is most likely a polar molecule. Whenever the electronegativity difference between two covalently bonded atoms is greater than 0.4, it is a polar molecule. Let's look at sulfur dioxide as an example. Sulfur's electronegativity value is 2.58 and oxygen's electronegativity value is 3.44. The electronegativity difference between sulfur and oxygen is 0.86. So this molecule is polar. Go ahead and find the electronegativity difference between selenium and chlorine. If the value you find is greater than 0.4 but less than 1.8, then it is a polar molecule. If the electronegativity difference happens to be greater than 1.8, then the compound you're looking at is most likely formed from an ionic bond. But if the difference is less than 0.4, then it is probably a nonpolar molecule. A final way I'm going to show you how to identify a polar molecule is by determining the net dipole moment of a compound. If it is not 0, then it is a polar molecule. Let's look at cis-dibromoethene as an example. In the bond between carbon and bromine, since bromine is the more electronegative element, the dipole moment of the bond is in the direction towards bromine. Both carbon-bromine bonds are on the same side of the compound, and therefore the dipole moments in the bonds are not in opposite direction, and therefore they won't cancel each other out. Similarly, since the carbon-hydrogen bonds are on the same side of the compound, the dipole moments are not in opposite direction, and therefore they won't cancel each other out. Therefore, this compound has an overall non-zero net dipole moment, making it a polar compound. Thank you for watching TutorTube. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos. Check out the links in the description below for more information about the Learning Center, and follow us on social media. See you next time.